Changing temperatures and varying winds over the seasons cause great fluctuations in Lake Geneva. The Lexplore research platform monitored the movement of water within the lake for a year to learn more about how natural factors influence the lake's mixing. The resulting analysis now paints a fuller picture of mixing in large lakes, which had previously only been studied over shorter time periods. From April 2019 to April 2020, Lexplore scientists recorded a set of data that includes wind speed, current velocity, temperature, and turbulence, all indicators that shed light on how mixing takes place in Lake Geneva's water column over the course of a year. They have just published their findings in Communication Earth and Environment, a publication of the Springer Nature Group. Mixing plays an essential role in how large lakes supply oxygen and nutrients to their fauna and flora. Yet, technical limitations have thus far hindered scientists from understanding how this phenomenon is affected by changes in solar heating and wind energy across the seasons. Doctoral research by a recent PhD graduate at EPFL looked at the impact of winter winds on the mixing process in Lake Geneva. The new study from Lexplore, however, takes that research to the next level through a year-long analysis that examines turbulent motions and mixing at a centimeter scale at all levels of the water column down to the deepest depth. The scientists were able to take measurements in all levels of the lake, from top to bottom. Their data indicates that turbulent mixing in the water column interior and at the deepest levels of the lake is 3 times stronger in winter compared to summer, a stark difference caused by more intense and prolonged winds during the cold months. This mixing primarily occurs in the lake's deepest levels, known as the benthic layers. The researchers also observed that mixing in spring and autumn occurs at intermediate comparable levels. During the summer, mixing is very weak in the lake's deeper levels because of light winds as well as the sun's heat, which prevents the density stratified layers from mixing. This research represents a big step forward in assessing the health of large lakes such as Lake Geneva, which provides ecosystem services and some of the drinking water used by the surrounding population. The Lexplore research platform has been a pioneer in this type of continuous monitoring since it entered service in February 2019. The floating laboratory covering 100 square meters brings together scientists from EPFL, the University of Lausanne, the University of Geneva, the Swiss Federal Institute of Aquatic Science and Technology, and the Alpine Research Center on Trophic Networks and Limnic Ecosystems. At their disposal are some 100 instruments used to gather data on the lake. The researchers says that their research demonstrates how important it is to continuously monitor large lakes so that they can identify the ongoing impact of climate change on lake behavior. It also shows that because of the crucial role played by wind energy in turbulent mixing, it is not enough to just measure the lake's temperature over the year. According to the researcher, this study proves that climate change will affect turbulent mixing in the lake over the long term. The exact extent of that impact, however, is anybody's guess.